we are going to talk to you about how to automate the operation of your MySQL fleet. It can be few MySQL, it can be dozens of MySQL or more, hopefully, and automate, many operations around that. So before, let's say, we go into the topic itself, I wanted to present basically the canonical team who works on everything SQL. It's mainly MySQL and Postgres. So we only work on mainly open source stuff. And those are the people, on the team. We have actually many of you here in the room. Alex, Nicola, myself, and Carl is here. By the way, we have as well some canonical colleagues who are here that are not part directly of this team, but that are working, mainly on the security part. So patches, backporting and so on, who are as well here. So thanks for coming. So the agenda quickly. We are going briefly, introduce the operator. We will talk a bit how it works, and then we'll talk about what it can do already, what we plan to do in the next iteration, and then hopefully we'll spend a good amount of time to have a pre-recorded demo done by Alex, and we will dedicate some time as well, hopefully, to your question. But please don't hesitate to interrupt us at any moment and ask all the questions that you might have. So let's get to it, yeah. So this is basically what we would like to do. The idea is that we would like you to be able to run, your MySQL operation on the stack of your choice. It's not only Kubernetes operator, as many people would expect from the word operator these days. Actually, our operator can work with VM and basically containers and snaps of that as well. Basically pretty much the same way. And the two operator, we have two separate repo for them that you can check. You can type canonical, GitHub canonical /MySQL operator or MySQL KDS operator, and you can check yourself. But from feature set, they are basically moving at the same speed and to the same direction, hopefully. Okay, so, what's inside that actually? So the way to look at it is the following. So we have basically an operator framework, canonical Juju, that we did for it, that you can see it as the control plane. So basically what will orchestrate the rest of those components. Then we have, let's say, basically a router layer composed of MySQL router that you can choose to deploy or not, depending on basically on your choices. And then in the database server layer, we have, MySQL server, obviously, but not only, we have as well extra backup. We have, a MySQL D exporter. We have MySQL shell. So we are using a lot of the components that all of you are doing here, and we thank you for that. And basically, we have as well some integration endpoints so that we provide not only metrics, by the way, from its metrics, we have as well alerting and log aggregation, and we can backup and restore to and from any S3 compatible storage. Set here is just an example. And here just, for read write endpoint, read endpoint, automatically we will create two different endpoints if you need to scale your read on the replica. So how it works, we'll go into a bit more details. Okay, so this is just, I'm not going to the details of Juju, you can look at it yourself, but you can see it basically as an alternative to Ansible or Terraform that will basically provision the resources on the cloud of your choice. You will talk basically to the API of those clouds and will provision the resources that you wish to use. Then if, here I'm taking as an example Kubernetes because I think that's what many people, are interested by these days, meaning running database on top of Kubernetes. But let's say the idea are pretty much the same if you choose to run your database on top of VMs. So basically, in Kubernetes, you will have a namespace dedicated to the controller or the control plane, if you wish. Inside that, you will have the API server that will interact with Juju, which is the control plane. We will have a database where we are storing basically all the metadata that we need in order to orchestrate the cluster. And then this is basically the workload itself, meaning, MySQL component. So the idea is always the same, pretty much on all the operator made throughout our operator framework. You will have the operator, so the logic of operation. In one container, next to it, there is another container, the workload, in this case, MySQL router, and here it is MySQL server and the other component that I did mention, and both of them will be collocated in the same code. Here, by the way, I put only two, but you can have as many as you wish, by the way, so this is just an example. And then in another stage for set, I didn't mention that, we will have basically the server part. And again, same thing, you have an operator dedicated to MySQL Server, here the operator is dedicated to MySQL Router, and you have as many as you wish. Actually, we are using group replication behind the scenes. Of course, we recommend at least 3, but you can have more. And again, you will have the same Kubernetes service created for you for your read writes and read-only traffic. So what it can do already, and we will show some of those features, in the demo, just in a few minutes. So those are the main available features. We recommend you to go to the documentation if you would like really to see the full list. So you can deploy a cluster based on group replication. You can scale up and down the number of instances, even to 0, meaning that you can basically remove all the instances, keep the storage, and then for testing purposes, you can basically scale up again to resume your testing. Automatic failover and self-healing. So automatic failover is actually provided by group replication, but in some, let's say, error situation, we try to self-heal the cluster by spawning a failing node and so on. Full backup restore from 3 compatible storage. We already do encryption and transit. We as well spent a good amount of time trying to make sure that whatever configuration you will supply, you will try to validate it against the available hardware, against the other part that you have, and do some automatic tuning. Meaning simple automatic tuning, but still some tuning. Like, we will try to maximize the amount of memory we allocate to the MySQL instance based on the amount of memory that is available basically in the machine. Minor version upgrade, something that we are doing right now, and the full observability stack. So just to make it a bit more concrete, this is how, and you will see it as well in the demo, this is how we deploy a MySQL server. Usually deploy, then the name of the operator. You will see here all the time, so basically just MySQL for the VM flavor, and K-test for the Kubernetes flavor. This is how you add units. This is how you do the same for the router. And this is basically how to do very basic user management, either for applications that are deployed within the same operator framework, but as well outside of the usual ecosystem. Full backups, so you will see it later on. I will not spend too much time. Same thing for the restores and minor version upgrades. So it just takes this, and you will upgrade to the latest version of basically that is available in our stream. This is again, all what it takes actually to enable encryption on the wire for both the MySQL server and MySQL router. And this is just some dashboard for the monitoring stack that we will have. Again, if you take on the documentation, you will see you can take, Charmed, MySQL, for example, and then you will see cost monitoring costs as in canonical observability stack, and you will see how basically to get those dashboards, rebuild dashboards. What we are trying to do, so the first line you can say is hopefully this year, the next one, or some of the next one, the iteration after. So incremental backups, they are not yet fully there. Deployment across clouds. So this is not only to say that you will have one cluster on top of Azure, for example, another one in your private cloud. We would like to be able to have part of it running in your private cloud and part of it running on the whatever public cloud you choose to help you, for example, migration scenario. Advanced user management to go from the basic up to the point where you have more predefined roles and as well integration with external IAM solutions. Out of the box hardware and setup, so this is basically is a bit linked to the security topic. So of course we have guidelines on how to, let's say, be compliant with things like CS benchmarking and so on, but we would like to implement as much as possible in the operator itself. So when you deploy something, it's already as compliant as you can get it, basically. ARM support, storage layout optimization, major version upgrades, schema upgrades, those are the things that we will work on next. Demo time, I think.
Hey, thank you, Mohamed. Jumping for funny part here. No live demo recorded, but I promise there will be interesting things, so try to follow me. As Mohamed said, we deploy in one command, so the first demo is pretty simple. I hope it's well readable. You just type juju deploy MySQL Kubernetes, amount of units you want to have. It's a cluster, 3 units. And let's use this example. It's lifetime video, no speed up, 1 minute average. There are 2 terminals. The one bottom shows juju status output, literally what's going on, and commands I am typing above. So as you can see, 3 pods created, 1 already initialized as a primary, 2 others are currently joining, synchronizing this data. Since database is empty, everything going pretty fast. Sure, I'm slightly cheating in here because Docker image is already in cache locally. So, but if you have good networking, should be as fast as this demo. The next demos will follow the same approach. So below you will see the statuses, above you will see commands I'm typing. For sure, it's great to show like Terraform apply, juju deploy, but how much manuals, multi-pages manuals was executed before to run this only command to show. So literally all the Bootstrap magic fits in 4 commands. On any Ubuntu 22.04 plus, you just install multipass, sudo snap install multipass. You start virtual machine, could be camel, could be LXD. Just 1 command defining how much CPU memory you need. You are going inside and you are typing the command you just showed. And this is a demo exactly you showed second before. No magic, how to remember, pretty easy, multipass. Going further. So this will be previously shown video, and I will try to slow down it a bit because before it was lightning talk, 5 minutes only, and it was extremely compressed. Video compressed in time, so things are speed up for better visualization. Again, we just add another model. It's a Kubernetes namespace, in fact. We are deploying MySQL there, only 1 unit. It's being deployed. You see primary. Now let's make something real. Let's use this database. And this is the best powerful of Juju. Like, for example, we took WordPress, we deployed, and we integrated it, which literally saying, hey, please make Juju, make magic that these 2 things can work together. So you don't need to copy-paste IP, password, credentials, database name between applications. That's all happen automatically and in a secure way. And also we dropped their Nginx ingress to access our WordPress in case. All that is currently being installed. You see that WordPress currently initializing database. So here receive credentials, database has been created automatically, isolated, secured, etc. And Ingress is currently waiting for IP address from Kates to give us access web interface. Meanwhile, we requested from WordPress the initial password, which is automatically generated, secure for that system. And as soon as we have password and as soon as we have IP address, we can open our browser. And browser is coming. When it's slower, it's a bit slower, but let's try to play this music. So we open in browser, we have our WordPress running. It's already storing data in database. Let's fill the data to proceed fast. Okay, we need credentials. That's looks pretty strange, but okay. We took credentials, we log it in, and we changing the data. Very strange because couple seconds was from another video or magic of storing videos on clouds. So we are changing things, we are saving the data, we are mentioning Juju team, kudos, great technique. One additional phrase to Mohamed saying that this is kind of replacement for Ansible or Terraform. It's not a real replacement, it's really empowering. So Terraform is giving you deploy things like, hey, I have Helm, drop MySQL there, and then you're creating huge Ansible playbook to upgrade that MySQL there, and this is growing. All that can be replaced with a couple of commands like you see here. Meanwhile, we already get our website running, and we want to backup it, obviously, because it's important data inside. So for that, we have a S3 integrator charm. Like concept, everything is a small charm. So if you need things to store on S3, you are dropping the S3 integrator. If you need external access, you drop data integrator, etc. And then your subsystem is growing and it can scale a bit later. So we have our database and we related our MySQL to S3 integrator. With that, MySQL receive access to credentials. We enter it above, bucket, pass, everything, and we can request list backups from our charm. You see there are some backups already because it was experiments, but we can the same way create another one command, no magic behind. Extra backup is great tool, doing the job great. HB Cloud send it to S3. Everything what you well know, just packed in one container with versions which are compatible, polish it to work well, and unified from UI point of view. So we made our backup. Let's go and destroy our data to see how backups, restoring from backup works. And that's a bit annoying, so let's speed up it a bit. So we are destroying our data, and the goal is to restore from the physical backup we already have. Let's drop browser in the corner. Let's type again common sense command like before. Restore backup ID, telling which backup you want to restore, nothing more. Things start in the background. We are updating the page. You see that WordPress already detected MySQL gone, no data, but things are going on the background, and as soon as it's completed, our data restored automatically. Couple commands. No black magic, no need to read a lot of manuals, everything tailored for you. And our website getting popular, it's growing, we need more power, we need to handle more users. As simple as scale application, and important to see, it's the same command for WordPress and same for MySQL, and will be the same for all other charms you need. So you don't need to learn a lot of different things, how to scale things differently. So we have already cluster. Meanwhile, you see we are updating web interface, so website is working, our database is scaling, our web server is scaling, continue handling our traffic. So this is completely invisible for users, and you can scale up, scale down during peak period, and users should not notice that. As Mohamed said, there should be reuse of the storage, so if you scale down, scale up, and your data, most of your data is there, then the rest will, the data will synchronize on the next start. Sure, all depends on the amount of data and how long we are storing things, but in general, that should work. Okay, super. We have website, it's running, it's handling a lot of traffic, but now some CVE came and we need to urgently install new version of MySQL. As simple as that, run, check for upgrades and refresh, Juju refresh to a new channel. In our example, we were refreshed from 8.0 stable to 8.0 edge. Juju has concept of risks, and you are defining which channel you want to track, 8.0, 5.7, we don't have them. As an example, you also can find out how risky you can be. You want to receive everything from nightly bills, or you want to receive something from stable, from beta, from candidate. In this case, we upgraded from stable to edge just to show an example. As you can see, important to mention that upgrade happening in unit by unit approach and with sacrificial unit concept. So we upgrade in the first unit, we are giving you a chance to check how it looks like. If you like it, connect it, select it. And then if you like it, you are resuming upgrade, and it's continuous upgrade of all the other units. We will come back to upgrade a bit later, because you see during our upgrade, our website stops working. That's because we are not using MySQL router here. And that was properly mentioned in Ubuntu Summit. So we are eventually coming to a next demo where we are upgrading with a router under the load, not just some website. So this is a video recorded just a couple minutes before I tried to increase the font size here, so you can maybe read it better what's going on. Again, in 5 commands, we are deploying the entire stack. We are deploying 3 servers, 3 routers, and 1 test application. Our internal tool, which as soon as related with database, start inserting data into it. We are waiting for deployment. A bit of explanations. What you see here is application part, where your applications are sitting, and units part, explaining how much copies of the same application you have for high availability. As you can see, primary is already elected, 2 more units are joining, and these are important things I wanted to show you, that sometimes what happens. You have errors, something doesn't work well, didn't work well. This particular example was executed on this laptop and recorded just 1 hour before. You see that on the top. And obviously, performance of that laptop is not enough to handle all that load with maximum performance load of the database. So some events have failed, but they automatically restarted and recovered from that state. As you can see, everything went stable, running, and we can continue. So we started in a new window, continuous writes into database, and small shell script written in 10 minutes, start selecting amount of records in each of 3 units, and showing us total records plus delta from the previous check. So we can see what's going on there. At that point, my laptop says, okay, maybe it's too much. The temperature, you see how it looks like, but the thing's still working, the thing is solid, and that's a great test for all the retransmits, timeouts, and exceptional cases. And with that load, we are trying to upgrade our database. Like, don't do that in production, but as I told you, this demo will have fun, so let's do it. We upgrade in MySQL router, again the same concept, first unit, the biggest ordinal, literally, the last one, will be upgraded first, and then to be paused, giving you a chance to check what's going on. In that particular moment, it's turned off, new image being downloaded, and chart will start. For visualization purpose, we are showing you now here two numbers. One is a version of router itself, and another is a pod spec revision ID. So you can see that 2 above are identical, 1 below is a newer. At this point, it blocks you and telling you message that you can either roll back if you don't like it, just juju refresh to previous revision, or continue with upgrade, just resume upgrade. But proper testing means you need to upgrade router server to check how they flies together. And if you like all that on new version, then you are going together. So now we are requesting upgrade of a sacrificial unit of server. More or less going on the same. You can see that writes on the unit number 2. There is a data there, but no new data coming. There was zeros. Now this unit started. It started synchronizing things slowly, all the data he missed. And he mentioned that upgrade completed. All 2 other units are waiting in queue before you are telling that you can resume upgrade. Red color in this case is not a problem, but we will improve UI. That's because this star here means it's a leader. And as soon as you're telling leader, please continue upgrade, and that's you are dying immediately, and then it's being terminated. But the process started, and it will continue successfully. So router, 1 by 1 finished. As you can see, data is still flying, being inserted. No problem. When router is over, you are repeating the same story for MySQL server. Like common logic for all steps, no need to reinvent a bicycle, no need to reinvent a wheels here. So second unit went to reboot, it stops receiving data. Actually, we cannot even connect it to get amount of data inside, it doesn't receive data from my peers. As soon as it started, it will currently be upgraded. As soon as upgraded, it started catch up to synchronize the data with neighbors. And in a second, it will be fully synchronized and return to a new version, working on H-track, both of them, on channel 80H.
So a few things were, well, let's say the demo was completed. So the concept of leader does not mean not necessarily primary. Yes. It's just the unit that is receiving basically the command, yeah. Usually we try, to align them, but there is no need to. And basically on the revision, you might ask, okay, what is actually the exact version of MySQL or MySQL router behind that? So in our documentation or release note, you will see basically what are actually the version of MySQL or MySQL router that we are shipping in those revision. You might ask like why we are inventing this revision, because in this like MySQL router or MySQL server, we are embedding many other things like MySQL shell and for example the Prometheus exploiter and so on. So we have one version to refer to like the combination that we did validate, and then within that release note for that particular revision, we can see what actually was shipped or what are the new version of all the components shipped in that particular operator.
And as Mohamed said, leader and primary in a cluster can be different, and this example here. So first unit is a leader of Juju and control internal events and processes, and primary is actually unit number 2. That doesn't change a lot, but gives you better understanding what's going on inside. And again, behind is just the Kubernetes, and Juju helps you to execute commands instead of running many different things and deploy exactly what you have tested, not guessing what was a revision, SH ID of Docker container, etc. And with that, we are finishing with the demo part and coming to your questions. I hope you have some. Sure.
Can you put up on the video and maybe like 20 seconds away from the end?
The last one,
Yes.
20 till the end.
Shut down one.
I wish.
Yeah, no, it's cool.
Demo syndrome, apologize.
Doesn't show up.
Yeah.
Thanks a lot.
Probably this box works well.
Yeah.
Oh, I think just you were disconnected. I will connect again.
Yeah, let me. Yeah, we are back.
Yeah, Alex sent you a PDF.
Exactly. So that was the video.
Basically, the question is whether we add the downtime or no.
There should be none, but if it happened,
I'm trying to understand the output on the output.
like here,
Yes.
so that means it was not able to receive to connect any the script. MySQL select.
I see where you know the markets.
I think it means 0, 1, 2 means all of the nodes.
Yeah, it's a 3 units, 0, 1, 2.
Yes, but they're on markets. And I'm seeing.
So then so only one gets to 0 at the time. So
Because
the other
it's
two are
our
getting
cover.
the data.
The plus means amount of data from the
Yeah, I
previous
think
check.
that's what the thing that was not clear because we can see it's 0, but it means only one of the nodes was 0. So the other one were processing data. It was not clear that 0, 1, 2 means the 3 nodes. That,
Okay.
I think this is what you mean, right? Okay. Yeah, I was thinking about that.
Okay, we'll improve next time. Thanks for feedback.
Probably you can show the last slide. If you can, let's, yeah. So just to say that please do not hesitate to contact us. I mean, we are pretty much open source, like even from roadmap perspective, if you have something that you would like, to see it coming or a bug or whatsoever, we would appreciate any contribution. And we are hiring as well. So you can apply here if you wish.